Welcome to this dialogue that we're going to have about graphs and applications of linear functions. And in this video, we're going to cover quite a few things because they should probably be reviewed for you. So we'll go kind of quickly through several different items, and let's just go ahead and jump in. The first thing we're going to do is talk about the formulas that you just need to know. These are formulas you want to commit to memory. You'll just need to know them in order to efficiently navigate through the types of problems that you will be facing. So let's talk about these things. And again, you want to memorize them. This would be a good opportunity to use note cards or some other memorization technique, but you really want to have these ingrained in your memory. The slope of a line between 2 points. If you know 2 points and you want to determine what the slope of the line is that goes between those 2 points, you can find that by designating one of the points as x1, y1, and the other point as x2, y2. And then you would take those two coordinates and subtract the y values and then divide that by the difference of the corresponding x values. So y2 minus y1 divided by x2 minus x1 will equal the slope of the line between those 2 points. Now, point slope form of a line, this is a really, really useful form of a line. And it is not emphasized so much in high school. But for any of you all going on to calculus, this would definitely be one that you would want to become familiar and comfortable with. The point slope of a line is really useful because if you have a point and a slope, then you can write this formula. And it is really derived by taking this bottom piece and multiplying it by both sides of this equation here. So we just think about it as we keep our y variable and our x variable here. We put our x coordinate of the point we know and the y coordinate of the point we know, and we put our slope here, and that will give us point slope form of a line. Now, one thing to say about point slope form of a line, because there are an infinite number of points on a line, there's an infinite number of point slope equations for any line. Because I can put an infinite number of points here, right? And the slope would remain the same for all of them. But that's one of the reasons why it's not emphasized in high school, is because there are so many different forms of it. Now, that is different from slope-intercept form of a line because slope-intercept form of a line is unique. There's one slope and one y-intercept for every linear function. And so this will be unique for every single line there is. And in this case, y equals mx plus b. The m is the slope again, and b will represent the y-intercept. General form of a line, this is ax plus by plus c is equal to 0. In other words, we're putting everything to one side of the equal sign and arranging it in xy constant. The two caveats that usually go with this is the first term should be positive, and a, b, and c should be integers. They should not contain fractions or decimals. Vertical line is always in the form of x equals some constant c. C is going to be a real number, and that's all you need to know. If you see something that looks like this, x equals 2, or x equals 5,000, or x equals negative 1/2, that means we have a vertical line. It's going through the x-axis at that value c. And likewise, a horizontal line will be in the form of y equals c, where c is a real number. And again, that c can be anything that's a real number. Negative 27, positive 420, 23, negative 0.11143. I don't know. I'm just making up numbers there. As long as it's a real number, a horizontal line can pass through it on the y-axis. Average rate of change formula, otherwise known as AROC. AROC is f of x2 minus f of x1 all over x2 minus x1. Now you may say to yourself, hey, that looks an awful lot like the slope formula. And indeed it does. And the only difference really is that slope is an average rate of change of a linear function. The average rate of change of every function can be written like this, f of x2 minus f of x1 over x2 minus x1. And so this can be used with every function there is. And really, average rate of change is nothing more than the slope of a line that goes through 2 points. But those 2 points are not necessarily sitting on a linear function. They can be 2 points on a parabola, but then you can draw the line that goes through them and find the slope of that line. And that's what average rate of change is. We'll talk more about that when we get to some average rate of change formulas. And then the last 2 things that you need to recall are that the slopes of parallel lines, they always have the same slope, and perpendicular lines have slopes that are negative reciprocals. All right, so these are the things you want to commit to memory. So let's do a little bit of math. All right, first thing, you should be able to take 2 points and determine the slope of the line that goes through them. So you're going to use that first formula, m is equal to y2 minus y1 over x2 minus x1, and sub in x1, y1, x2, y2. Okay, so if I do that, then we will just say, okay, negative 2 minus 4 divided by negative 4 minus negative 3 will equal the slope of the line that goes through these 2 points. And then we will be careful with our signs and simplify. Negative 2 minus 4 will give us a negative 6 in the numerator, and negative 4 minus negative 3 is the same as negative 4 plus 3, which is negative 1. And so we end up with negative 6 divided by negative 1, which is a slope of 6. This is a rise of 6 over a run of 1. So going up and to the right, which means the slope is increasing from left to right. Anything that's got a positive slope is going to increase from left to right. All right, next thing is, let's try this next one, slope of the line through the points 4, negative 1 and negative 1, 5. So the slope here would be 5 minus negative 1 divided by negative 1 minus 4. 5 minus negative 1 will become 5 plus 1, which is 6. And negative 1 minus 4 is negative 5. So we end up with 6 divided by negative 5, otherwise known as negative 6/5. We have a positive rise and a negative run. So this is up and to the left. Okay, so if it's going up and to the left, if I'm thinking about that line, it's going down from left to right. It's falling from left to right if it has a negative slope. Okay, and I could also think of this, right, as negative 6 over positive 5. And if I thought about it that way, then I'd have a negative rise or down and a positive run to the right. But still you have a line that falls from left to right. Okay, take a second and calculate the slope of this next one. Calculate the slope of the line that goes through 5, negative 3 and 2, negative 3. Pause the video, write it down, and then restart your video. Welcome back. And we should end up with a slope here of negative 3 minus negative 3. over 2 minus 5. Okay, and that negative 3 minus negative 3, that's a negative 3 plus 3, also known as 0 over negative 3. A 0 in the numerator, that means I've got 0 thirds, or 0 negative thirds even. And that means, no rise, but only run. So no rise, but only run. So in this case, I've got no rise. I'm not moving up at all or down. I'm just running. And so what that means is I have 0 slope, which means that this is going to be a horizontal line. And do the same thing with this next one. Give it a shot on your own. Pause the video, take a second, and calculate this. Come on back, and we'll try this out. Slope of the line that goes through 12, negative 1, and 12, 7. We would have 7 minus negative 1 in the numerator and 12 minus 12 in the denominator. And in this case, we would end up with 8 divided by 0. And when we have a 0 in the denominator, we know we can't divide by 0, which means we have an undefined slope. And think about this. This is saying I've got a rise of 8 units, but no run. So I've got a rise, but no run. And so in this case, when you have an undefined slope, you will have a vertical line happening. And let's move on to the next part. When we are asked to write the equation of a line in point-slope form and or slope-intercept form, you're going to need a slope and a point on the line. To write the equation of any line, you're going to need those two things. Okay, so let's look at this example and analyze what we have and what we need. Okay, let's look at this example. Find the equation of the line through the points 2, negative 5, and negative 3, 5. So we're going to look at finding it in point-slope form and also in slope-intercept form. What are we given? We're given a couple of points here, but we are not given the slope. But we just developed that skill, right? We know how to find the slope of a line when we have 2 points. So the very first thing we're going to need, no matter which form of the equation we're looking for, is the slope. So let's calculate the slope of that line. We're going to use that slope formula again. So y2 minus y1 divided by x2 minus x1. So y2 minus y1 will be 5 minus negative 5. And our x2 minus x1 will be negative 3 minus 2. We're going to simplify that up, and the numerator will become 10, while the denominator will become negative 5. And so our slope will be negative 2. Now, if I'm looking for point slope form of the line, all I need to do is choose one of the points that I'm given, either 2, negative 5 or negative 3, 5, and the slope of the line, okay? And so if that's what I'm doing, I'm just going to sub the things into the appropriate formula. So point slope form, again, is y minus y1 is equal to m times x minus x1. I'm going to choose one of the points and sub it in for x1 and y1, and then our slope that we just calculated in for m. Which point do you want to use? If you use the second point, negative 3, 5, it will look like this. Y minus 5 is equal to negative 2 times x minus negative 3. Now, the only thing you're going to do is get rid of the parentheses in the front here and clean up this expression that involves x. So x minus a negative is going to be x plus. So we'll end up with y minus 5 is equal to negative 2 times x plus 3. And that's all you do with point slope form. You don't clean it up any more than that. I know you're tempted, but you just don't do it, okay? Now, if I want to convert this to slope-intercept form, The only thing I'm going to need to do is distribute this -2 through and move this -5 to the right. Okay, so I'm isolating y and putting it in the form of y equals mx plus b. So if I distribute, I'll get -2x minus 6. And now let's add this 5, and we'll end up with y is equal to -2x minus 1. Okay, so a couple of words here before we move along. One is that I could have just as easily chosen this point to -5 and used it for point slope form. There's no advantage to using one point over the other, especially in this case where you have a positive and a negative in both of the coordinates. Now, if you had both coordinates being positive for one of them, that may be easier, but it doesn't really matter. Neither one is more correct than the other. And then the other thing is, no matter which point you choose, you will end up with the same slope-intercept form. Okay, so while this may be different, this will always end up being the same. Okay, let's move along. Graph the equation of a line in slope-intercept form. Okay, so that should be fairly easy. Let's start with this example. Write the equation 3x plus 2y equals 10 in slope-intercept form. Now remember, slope-intercept form is y equals mx plus b. So I want to isolate this y. I want to first move the 3x to the other side and then divide everything by 2. So let's do that. Let's first subtract the 3x. And so we end up with 2y is equal to -3x plus 10. And now we'll divide everything through by 2. And we'll end up with y is equal to -3/2 x plus 5. Okay, so this means that the slope is -3/2 and that the y-intercept is 5, which makes graphing very easy. Let's plot the y-intercept on the y-axis. Okay, so we're just taking that 5 and plotting it on the y-axis. Now we're going to use our slope. Our slope is -3/2, which means a negative rise and a positive run, or a positive rise and a negative run. But I'm going to take a -3, 1, 2, 3, and a +2, 1, 2, and go ahead and plot that point. And I might do that again. From that new point that I plotted, down 3 and right 2. And go ahead and sketch a line and connect those dots. And there we go. We've got a nice graph using our slope and our y-intercept. When I'm thinking about writing and graphing lines of vertical and horizontal lines, remember we talked about vertical lines will always be in the form of x equals, and horizontal lines will always be in the form of y equals. Now, sometimes students get confused and forget which one is which. One thing you can do here is you can recall that it will always be a graph of a line that crosses the axis that it names at the named value. So in other words, this is going to cross the x-axis at the point -9/2. Okay, so we know that it's going to cross the x-axis, which means it's going to go up and down, right? If it's going to cross the x-axis, it's a vertical line. And then it's going to cross at the point -9/2. Now, where the heck is -9/2? Well, you need to think about what -9/2 is really. And to do that, you can think of it as -9 divided by 2. And 2 will divide into 9 4 times with 1 left over. So this is really -4.5 or -4 1/2. So this will cross the x-axis at -9/2. So we're going to plot that point on the x-axis at -9/2, and we're going to draw a vertical line right through there. Okay, that was pretty easy. Now we're going to do the same thing on the right here, except this is going to cross the y-axis at 28/5. Now again, we need to think about what is 28/5. How many times does 5 divide 28? 5 will go into 28 5 times with 3 left over. So this is 5 3/5. So this is going to be between 5 and 6 on the y-axis. So let's plot that point, and we'll draw the horizontal line that goes straight through there. And that's all there is to writing and graphing vertical and horizontal lines. Sometimes we will need to identify the slope and the y-intercept of a line from its equation. And we've done that before, right? We did that a minute ago. If the equation is in slope-intercept form, it's easy. All we have to do is identify what m is for the slope and what b is for the y-intercept. Here is an example of a line in slope-intercept form. Y is equal to 2/3 x minus 17. So if I know that if it's in slope-intercept form, great. I can just choose the m value, which is the coefficient to the x. So the slope is 2/3. And the y-intercept is the constant on the other side. So the y-intercept is negative 17. Okay, but if the equation is not in slope-intercept form, the first thing I need to do is convert it. Put it in the right form. Solve for y and put the terms in the right order. So in this case, I want to isolate the y. So we'll make this into 6y is equal to negative 3x plus 12. Now I'll isolate the y by dividing through by 6. Divide everything through by 6, and I end up with y is equal to negative 3/6, which reduces to negative 1/2 x, plus 12 over 6, which is 2. So then, what is our slope? You should have answered the coefficient to the x, which is negative 1/2, and the y-intercept is positive 2. The next thing we'll look at is using the intercepts of a line to graph the general form of the equation. Now this is slightly different than using slope-intercept form because we're going to use both the x-intercept and the y-intercept of a line. So let's think for a second. An x-intercept is something that falls on the x-axis, right? So let's just consider this point here. This point on the x-axis is 4, 0. How about this point on the x-axis? That would be negative 5, 0. How about this one? Negative 2, 0. What does that mean about the y value of anything that's on the x-axis? Or hopefully you noticed that the y value will always be 0. So we can use that to find the x-intercept of any graph because we can substitute a 0 in for y and then solve for x. And likewise, for the y-intercept, I can do the same thing. I can substitute a 0 in for x and then solve for y. Okay? And so in this case, if I am going to graph by using intercepts, I'm going to find both of these intercepts first, plot them, and then sketch the line between them. So let's look at this equation, 3x plus 6y minus 12 is equal to 0, and find the x-intercept by substituting 0 in for y, so we'll put a 0 here, and then solve for x. Okay, so 3x plus 6 times 0 minus 12 is equal to 0. Well, what happens here? This 6 times 0, that just disappears, right? So I'll end up with 3x minus 12 is equal to 0. So 3x equals 12, and x will equal 4. So on the x-axis, I'm going to plot the point 4, 0. Now I'm going to do the same thing for the y-intercept, but this time I'll put a 0 in for x. So I'll put 3 times 0 plus 6y minus 12 is equal to 0. Notice that this will disappear because it's multiplied by 0. So I'll have 6y minus 12 is equal to 0, or 6y equals 12, so y is equal to 2. I'll plot that on my y-axis. and then I'll just connect the dots and arrow at the ends. There we go. Well, that will wrap up this video, and we will have one more video that will talk about average rate of change and parallel and perpendicular lines, and I'll see you then.